Hello and welcome to the Saltstack demo for Dimension Data Cloud. I am referring to a README that is hosted on a GitHub under the /airmetal salt-dimension data repo. And you can refer to this README to reproduce this entire demo. And I'll try to stay to script as much as possible. And you can see a whole set of steps here, 0 to 6, and there's also an optional step to install software on the VMs. Now, here we have a set of instructions to download the install script. So I'm going to open the command prompt, and maybe I'll choose a better color here for better visibility. Hopefully this scheme should be easier on the eyes. See if I can actually make it a little bigger. Okay. So first thing we're going to do is, and I'm copying and pasting commands, so it's going to be very dead simple on as to what I'm doing here. So this will actually download the script, as you can see. Oh, actually, it would help if I actually SSH into the machine that I had specifically created for this, right here. We accept the SSH search. Let's put in our password, and in we go. So this is a clean Red Hat Linux 7 machine. And let's go back to our instructions here again. Let's try this again. So we have downloaded the install script. Let's change the permissions on that to execute it. And let's execute that script. And what this will do is it's going to install a whole set of prerequisite libraries that are required, more so because we are using the development stream of Saltstack, so there's obviously more requirements that need to be installed, and also needs an updated Python library, because the one that's installed vanilla out of the box, it does not meet some of the requirements required by Apache libcloud, which is another library that we use under the covers, or actually that Saltstack uses under the covers. So this takes a few minutes, and I'm going to pause the video. Alright, so looks like our install has completed, and these are the last few lines. It usually takes about 10 minutes for this entire process, so that's why I fast forwarded towards the end. And I think at this point we are ready to try out a few commands and also look at all the different files that were pulled down. And some of these files are templates that you can reuse, and also it sets up a good base for an end-to-end demo. So let's go back to our GitHub README file for this demo. The first thing we'll do is create a virtual environment. If those of you who are not familiar with typical Python-based virtual environments, they're essentially these reusable, partitioned virtual areas that you can create to do any kind of Python-related execution or development without impacting, let's say, your global environment or your Python that's required by your system. So it helps you to keep a very clean and maintainable environment without clobbering your global environment, and perhaps gives you also an option to try out, create different environments for different purposes, where you may have to install certain prereqs, but you don't want it to affect your global environment, or perhaps you want different versions of different Python projects which have different sets of versioning requirements or libraries. Essentially helps you to partition and keep everything in order without clobbering things over. So it's a very useful technique that's pretty common when you're doing Python development. So what we'll do is, as part of the install script, it actually created a virtual environment, and now what we're doing is we are logging into that virtual environment for Python. So let's get in there and let's see what we have. Let's take a look at some of the files that were brought in during our installs process. So that's the tilde/.salt is the home directory for this virtual environment, and you'll see a whole set of binaries that are specific to Python here, and also there's an etc directory that is specifically created for Salt. And let's see here. So what you can see is there are a set of directories called Cloud Maps, Cloud Profiles, Cloud Providers. Essentially, it's an hierarchical representation of how files and configuration files are laid down on the system and how they're executed. So cloud providers is essentially a definition of different cloud providers such as Amazon, Azure. And that's where we also may have something specific to Dimension data, and we'll go into that shortly. After that, we have cloud profiles. So cloud profiles, once they're dependent on the cloud providers. Once those are defined, the cloud profiles will define what is the configuration of the image, all the different properties, right? Passwords, operating system names, image sizes, disk configurations, all those type of things you can define there as a template. So those are called profiles. And then maps are essentially what allows you to group those templates. So let's say you want 3 of Ubuntu with certain configuration, or 6 of Red Hat, Linux. So what it allows you to do is sort of group things together in profiles and add orders of how things should be executed. So that's what maps allow you to do. So those are the 3 basically what we're going to use. We're not going to be, we may look at minions and master configurations shortly, just because it's specific to the demo and it might be useful. And of course, if you're not already familiar with minions, minions are the slaves or the machines that are created by the master. The master is this machine where we're going to be running these commands, and this will serve as the central place for managing all the different servers. Now, let's go back to our second step, and let's view this file here. So this is the provider. Notice right here is the provider for Dimension data. And what I'll do is I am going to put in my user ID password to our MCP cloud account. And once we've put in the ID and password, we are good to go. The next thing we are going to do is look at public or private profile. So the way I've defined it is, this is more for the demo purposes, and what we have is a public network profile is essentially what we're doing in this demo, where I am trying to provision a cluster of servers from a network outside the local VLAN. It could be within, in this case, it is the master is in the Dimension data cloud, but I could have easily been on my home laptop and running these commands, and where my laptop would be the Saltstack master server. So essentially it allows you to be completely isolated from your target cloud, whereas in the private template you would have to deploy the master within the same VLAN as where your target servers are going to land. And that's essentially the functionality that's available today out of Saltstack release. So obviously that's fairly limited. So we are going to do something here with the public network, and so we are going to create VMs and associate them with public IPs, and those are the public IPs that the Saltstack master is going to communicate with those servers, slaves, or minions. So let's take a look at that configuration and what it looks like. So for the most part, everything is pre-configured. Try not to make too many changes during this demo. So what you can see here is the reference to the provider. If you recall the provider file that I opened initially, it has a name called my dimension data config. That's what we refer to here. Image is the name of the UID of the image that came down from Cloud Control. So this is a Ubuntu image, I believe, and that's the unique identifier of that image. And recall that if you're familiar with Cloud Control and Dimension Data Cloud, that this image ID is not transferable across different data centers. So this ID will change even if it's the same OS or configuration for a different data center. So ensure that that's available. This is in NA9 that I'm doing in the Americas region. So that's what this image ID is valid for. So you may have to do a query and see which image IDs are available in your target data center region, and then replace it with the image ID here. And then of course size you can ignore. This is sort of a carry-on parameter that's it's kind of a placeholder for now. And auth is a default password of the server. Location is NA9, that's the data center. Remote client is a flag to indicate that this will be configured over a public network or over the internet. Description is going to be the description of that goes in the description field of the server. Network domain is the target network domain that's going to be created if it doesn't exist already. Same thing for VLAN, and that's the VLAN base IP that's going to be chosen for that VLAN. Is started, of course, is going to bring up the server in a started mode. Minion this is the configuration specific to Saltstack, where the server will be configured to point to the master, which is the current machine right now. And I believe this machine has an IP address of, so let's change that here, 4171. I'm looking at the SSH address here. And if you can also look at it over here in Cloud Control where you've created that, or of course if it's not in the cloud, wherever your public IP address resides, that's what I'm pointing it to. And roles, yeah, you can also give labels to it that Saltstack keeps track of. So whatever these servers are, once these servers are created, you can have a label associated with them. So when you do queries and organization, you can actually look them up by this role. Let's save this file. Okay, now let's go back and also look at our maps. So we're going to look at an equivalent map that I had created. So the map is actually going to point to the profile. And the profile is called CentOS 7, and it maps to 3 instances of that profile. This is Web 1. So the names of the servers are going to be called Web 1, Web 2, and Web 3. And I think I didn't point this out, but let me go back here in the profile. Notice that the profile is called CentOS 7. I'm basically just, it's very straightforward. It's just taking this name and injecting it into the map right here. Okay, so now we are pretty close. We can do our first test and see if we can actually list images. So this is a command that this is a Salt Cloud command, which is a subcomponent of Salt, and essentially all Salt Cloud related actions. So if this works, this is a confirmation that our environment is all ready and set to go. So as you can see, we have all our different image configurations available in our North America region listed here, which confirms that we have configured our environment correctly. But now let's do something more interesting. What we're going to do first is we're going to create those 3 servers. Now we can create those 3 servers in parallel mode, which is all at the same time, or we can create them synchronously. Now you would ask, why would I never want to create in parallel mode? Well, the issue is that there is in the Dimension Data Cloud currently shared resources like network, for instance, like network domains, VLANs. They can only be operated on in a serial fashion. So I cannot attach resources until that network resource has been created. So when you issue something with -p command and you don't have a network domain or a VLAN already created, there's going to be contention, and that's going to cause some failures. However, the good news is that these commands are idempotent, which means that even if certain things fail, you can run them again and it's actually going to bring it to the right state. So, but of course, if you're not willing to experiment something like that and willing to wait and have one clean shot, then you can skip the -p. And I'll also dash the -l debug statement so you can see a little bit more verbose as to what's occurring in this. Alright, so this is pretty much the standard output, and I think I used the -d, which is probably not the correct option. So we have to remove -d's actually destroy those VMs, and since those VMs don't exist, we don't need that one. So we just remove that, and now what will happen is it's actually going to try to create them. And so now it's asking if you want to create those. Yes, please do. And at this point, it's a fairly lengthy process. It's probably going to take about 10-15 minutes for this to run. And we are going to come back and take a look at this and see if we had any success. All right, so while our VM is getting added and available for further configuration, let's view one more area that we haven't talked about. Open another window here. And let's look at, see if I can make this bigger. It would help if I SSH first. Okay, now if I look at the master configuration, so what we have here is essentially an auto-assign file, which essentially says that all the servers in this file are automatically approved to be authenticated. The authentication happens by the servers. Once they're created, they send secure keys, which the master has to accept. So this automates that process, which does not require any kind of intervention by a human, and essentially makes it a complete end-to-end automated process. Now the other 2 things here, what you see is the file roots. File roots is essentially the base directory of where all the SLS or the configuration salt state files reside. I'm not going to talk too much about it, except in this demo at least, besides that those are the files that are pretty much the templates equivalent to your chef cookbooks or your Ansible playbooks, for instance, or your Puppet manifests. So that's essentially the root directory where all those files reside. Reactor is something very interesting, and I'm finding it to be a very useful feature of Saltstack that allows you to really tap into the event bus or the eventing system of Saltstack. And as you may recall, Saltstack is heavily based on messaging infrastructure, and that's what allows it to scale and the performance that it touts and is a differentiator compared to the other configuration management tools. But it also allows very seamless integration with other third-party applications, and also even the workloads within its ecosystem. So that's how we are using Reactor. So the use case, if you may recall, is that once those servers are provisioned, we do want to essentially install software. That's the whole reason why we're provisioning servers, right? So what we want to do is we want to automate that process in the same uh, orchestration or same process, where once the servers are provisioned, that it automatically knows to kick off the right set of application that needs to be deployed on those servers. So that's what a reactor helps you do in Saltstack. And here is a list of a couple of things. So you can see the first dash right here is these are the topic names. If you're familiar with the messaging terminology, topics are essentially those namespaces where messages get assigned to and or land, and then you can search and retrieve or subscribe to topics to get your messages. Essentially the same concept here. So this is your topic that we are subscribing to within our Saltstack configuration. And once that message is received on that topic, this file right here is executed, right? Similarly, so there's one for minion, there's one for job, and you can create, obviously, they're predefined topics, and you can create your own custom topics, like this one right here, front-end load balancer pool update, that invokes, once it sees a message on this topic, it's going to trigger this SLS file right here. So I'm going to save this, exit out of here. And another thing we need to do is we need to ensure our minion is configured correctly. So we should probably need to fix this. And that should fix our minion. So essentially it tells, once the server is configured, it configures the minion on that server to point back to this master on the correct IP address. Now let's take a quick look at those reactor salt state files. We look at basic. This is what it looks like. Essentially what it's doing is generating a message that this minion on this server has started at, well, this is a hard-coded timestamp, although that can be made real time. And essentially the idea is that it would generate this message on that topic. And once that message is generated, then it can execute another script. Okay. So let's take a look at job. Okay. Now in this script, what it's doing is it's getting the job information that actually executed. So I'm trying not to get too much into the technical details of Saltstack. It might be confusing if you haven't really gotten the background, and those are fairly expanded topics. But essentially what this is doing, this is a specific salt state file for the job underscore topic that I just showed you, right? And essentially it's also doing an echo of a command right here, and there are all these substituted parameters that you can pass in, and these parameters are coming from the Salt's native, uh, in lack of a better word, configuration management database, and that's what they call grains, right? Well, there's grains and pillars. There's slight difference between the two, but essentially that's where this information is stored about everything that SaltStack knows about in its ecosystem. And you can pull in information from there and then inject it into your scripts. So that's essentially what's happening here. There's also another one. I don't think so this actually works, and I didn't go as far as actually making it, doing some additional work to actually make it work. It will deploy the software, but the configuration doesn't quite work. Essentially what this is it's a script to invoke a set of configurations where you can load balance the HTTP traffic across the 3 servers that we spun up. So I think we are not going to go as far as that. We're just going to confirm if each of those servers has an HTTP server listening on port 80. So that's essentially the 3 files that we have, and I think there's the last one here. This is the state file that will be more familiar with sort of the non-reactor type deployments, where you're typically configuring software, doing configuration management on servers. And essentially here we are deploying an HTTP server and just specifying its state installed, so which ensures that it's installed with a set of configuration files, and we're actually pointing to where the conf file is with the right permissions and the right IP address that needs to be in that conf file, and then the service is getting updated or restarted. Pretty standard stuff, like any other config management tool. Alright, so now let's take a look. Okay, so it looks like one of our servers only succeeded, because you can see web 3 is false and web 1 is false, and all this information here for web 2 is an indication that it worked. But has it? So let's check at this point. So we have our server on NA9, I believe. Let's check. Let's make sure. It's called web 2, so let's go to web 2. Well, it does come up, so we want to make sure it's the right netdom Saltstack. That's the name of the network domain we had defined in our profile, and with the Salt VLAN as the name of the VLAN. And so we have one server, and it's assigned a public IP with a private IP address, but we still are missing web 3 and web 1. So like I said, this is an idempotent execution, so we can run this command again and let's see what happens. So it detected that web 2 is already available, so he's going to skip that and he's going to try and create web 3 and web 1, and we are going to fat fingering there. So let me try again. And so off it goes, and it's going to try and create web 3 and web 1. And so you may have to give it some time, another 5-10 minutes, and we're going to hopefully have those 2 servers available and ready to go. Now, one thing I did not bring up here, which might be a good idea, is to bring up 3 or maybe two different windows. Let's do that. We have to bring up 2 different windows. Okay. We're running out of real estate here. Okay, so what we'll try and do is we're trying to keep a close watch on this. And this will be a good demonstration of how the reactor system is working. Okay. Apologize for this taking a while, but okay. If I can line these up correctly, maybe should move these like here. And make sure we don't lose anything out of our view. Okay, and let's open that browser and let's see if we can run this command right here so that you can see the salt state. Oops, it'll help if I copy and paste right. Oh, we did forget to source. We have to get into our virtual environment. Now let's run that command. And we have another one, salt command. So here what we're doing is we are starting up the salt master. And the salt master is going to initiate the starting up the reactor engine, and that's how it's going to be listening to events. Actually, we should have done that in our first invocation, but hopefully we'll get it right this time. What I'm doing here is I'm activating I need to SSH in first. Keep forgetting that. Okay, and we are going to have this up and running. So here's the salt master. That's up and running now. In fact, actually, we don't need this third one. I was mistaken there. Okay, so we'll just keep a close eye on this. And once the servers are created, you will start seeing things start moving in these windows. And essentially what's going to happen is that you're going to start seeing the events showing up on this window, and of course the general overall debug from the Saltstack's master server is going to show up here. You can also see these different keys that are being generated and found from the minions as they get created, and that's all going to be logged in here. So I'm going to fast forward the video so you can get to the end state and see how things are going. Okay, I decided not to wait all the way till the end because there was some interesting information that I could definitely show you. And here you're seeing the private IPs or being mapped to NAT rules and the public IPs. Hopefully, also you notice that it has the Salt server has accepted 3 minion keys. That means those servers were authenticated. And what you're seeing here now is a whole set of bootstrapping scripts that Saltstack is running, and on the individual VMs that those have been created on MCP. And that's all the information that you're seeing from those SSH sessions that's coming up here. And so this also takes a few minutes to run. So I'm going to pause till we reach a little closer towards our reactor configuration. Okay, now if you can see, we have these new events that showed up. Web1 created, Web1 deploy script. That was the script I just previously mentioned. So Web1 has been deployed at this public IP address. And there should be a few other events coming up shortly. I believe it's still working on Web3. It has already worked on Web3. So let's take a look. Did everything succeed? Web3 is up and running. Public and private IP addresses are present. Web2 was already running from a previous execution. Web1 is up as well. Alright, so now let's take a look and see if we actually have all the 3 servers, just to be sure. And we are good to go. Now, one more thing we need to do is we need to open up our ports. Well, actually, I take that back. I think we already have. Oh, never mind. We actually need to have our ports. We need to have a firewall rule for HTTP traffic so we can test our HTTP server on each of those machines. Let's just leave it for any right now. Let's just add all those IP addresses from the SSH hosts, or actually the Salt minions. There's so many ways to refer to the same machine. Should add also Salt minions or server VMs that were just recently created. Now let's verify if our HTTP server is available on each of these servers. I'll just pick one IP at random. Let's see if we can bring that up. And here we go. We have an Apache web server installed as part of the reactor configuration. So there you have it. You have an end-to-end demonstration of Saltstack on Dimension Data Cloud deploying software. And I know we went back and forth several times, so just to reiterate, and hopefully you can follow this link that's mentioned here, and I'll try to post it as the subnotes for this video. But at a high level, what we did here was we downloaded Saltstack, the development repo, using an install script. And note that this install script has been designed for Red Hat Linux 7 for now, probably updated for other operating systems, but at this point it is mainly to create a demo environment, but I'm sure you can leverage the same script for other environments with some minor changes. So we downloaded the script, changed the permissions, and installed the development environment. Then we activated the virtual environment for Python and brought that into our shell. After that, we looked at some of the configuration files that were brought down and for the most part pre-configured to show this end-to-end demo. We looked at the Salt provider directory, and under that there's a dimensondata.conf file where you would enter your cloud control account, username and password. After that, you look at the cloud profiles. Cloud profiles were configurations of your server, where you would define um, things like the image ID of the operating system and disk sizes, RAM. You could definitely do that. I don't think so. I've done that to that extent, but you can get fairly complex with these profiles. So we looked at that. We did some minor changes. One of the things we had to change there was also the IP address of the salt master, so that the minions were pointing to the right IP. We also looked at the map files, which are a collection of profiles. So we didn't have to change anything there. We used it as is. That was the die-data-web-centos.conf file. Then one of the steps actually we missed, at least I missed talking about, was to open up the MCP firewall ports for the Salt Master for 405, 4505, and 4506. These are the ports that the Salt Master communicates over TCP or 0MQ messaging protocol. After that, we ran this command here just to test. You can copy and paste it on your command line to see if your configuration is working, and we demonstrated that was working. At that point, you can run individual commands to create servers, destroy servers. We skipped those commands and we did this right here, where we tried to create multiple servers in parallel using the -p command. And you may recall that I did mention -p may not be ideal if you're trying to create network domain and VLAN at the same time, and it may fail creation of some of the servers, but you can run the command again and it should complete whatever remaining servers were errored out in the first run. And there's a -d flag that you can run exactly the same command and it should delete the servers that were created. Another thing that we did was to look at, one thing I would note is that perhaps the order of this is a little bit off. Before you run the create commands for the servers, you may want to do this optional step first if you do want to deploy software, right? Up till here, it's just purely the infrastructure. That's why I think I had it arranged this way. But if you want to see end-to-end right away, then maybe before you run the create command for multiple servers, then you may want to do this step right here, the optional steps. So take a look at the master and minion configuration. Make sure you update the minion. There's an IP address that should match the Salt Master's IP address. Take a look at the SLS, the state files for Salt. And I did go through those a little bit, but not in a lot of detail. These are the Salt files that are looking at events as they're getting generated on the event bus, and those events are then mapped to different state files or different commands to do whatever orchestration you want to achieve in your pipeline. And also you may want to, I don't think I covered this one, there was an autosign.conf file that is actually for, you can create regular expressions for all the hosts that you want the Salt to accept as by default the public keys for, so they are already authenticated. Otherwise it queues them up and you have to manually go and run commands to accept those. And I finally run these two commands in separate windows. This will start the monitoring on the event bus, and this will start the Salt Master, which triggers the underlying engine and reactor. And then go back and run this command. Then you will see a lot of output in these two windows. And once everything is complete, you can go to the IP address of one of the servers and see that you have an HTTP server installed. So I hope that was helpful, and good luck with Saltstack.